Hey, Algebra 2, we're back. So we're going to start week 6, which is application of trigonometry, the word problems. So I will have another video on the clinometer or clinometer, whatever you want to call it. Either way is fine. But today we're going to look at some more word problems. I know you're excited about that, excited as I am. So we will use our trig ratios. Some of the times the pictures will be drawn, some of the times they will not. So a nursery plants a new tree and attaches a wire to it for support. The wire is attached to the tree with the stake in the ground, which is right here. So there's your stake in the ground. And here's my tree. It wants to know the height of the connection point to the tree. So they already tell you that's going to be X, right? So then you have to think, all right, well, here's my angle. So if I had to draw an arrow, hey, look at that. I did an arrow that looked pretty good. Then the arrow would tell me, right, that that's my opposite, right? And then this is my hypotenuse. So that should tell me that that should be a tangent for that. So if I turn off my drawing tools, then actually that's not a tangent, that's sine, because it's opposite over hypotenuse. So it should be the sine of 42 degrees equals x over 8. So you would set it up that way, and then you would solve for x by multiplying both sides by 8. So hopefully that will be something that you can do, multiply both sides by 8. Looking down here at the next picture, it says we have the top of a fire tower. He looks down at 40-degree angle. Well, if that's 40, then we know, right, that if this is 40, then this angle here is also 40. So we would label that to be 40 as well. So we have a 40 here and a 40 here because they're alternate interior angles. And then I would say, let me use that arrow since I discovered that, that this guy right here would be my opposite. And this guy here would be my, well, this guy would be my hypotenuse, right? And then this guy here would be my adjacent. So what trig function uses opposite and adjacent? Well, that would be tan. So then I'll turn off my drawing tools and I would say the tangent of 40 degrees, right, equals 45 over x. Well, x is on the bottom, which means I have to do a switcheroo. So I would say x equals 45 divided by the tangent of 40. And that's how I would figure out how far it was from that guy to the base of the tower. So that's what I want to do for that one. Moving on to number 3. The shadow cast by a 10-foot lamp when the angle of elevation to the sun is 58. So a lot of this is done for us. The only thing that I would have to do is, again, think 58 degrees and, again, draw my little arrow saying, oh, it goes to here. So that would be my opposite. This is my hypotenuse, and that's my adjacent. So, again, it would be tangent. It would be tangent again. So I would go and I would say, tangent of 58 is equal to 10 over x. Again, I would need to do the switcheroo, so I'm going to let you finish that, and I'm going to go down to the next one. A ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. So it wants you to know, it wants to know what this angle x is. So I'm going to go ahead and do that. See my big arc there for my angle x? And then I'm going to get my arrow key and I'm going to say, oh, It's hitting this side right here. So that's my opposite, right? That's my opposite. And this is my hypotenuse where this very handsome young guy is. So that's my hypotenuse, which means that's my adjacent. So then I would say, okay, wait a minute, that's tangent, right? That's tangent. So I'm going to come over here and I'm going to say the tangent of some angle x, I don't know what the angle is equal to my opposite, which we said was 6, right? 6 over 15. I need to do my reverse trig function, so that's going to be the inverse, and I'm going to do, just give me a second, -1 of 6 over 13. 15. So how do I put that into my calculator? So I'm doing an inverse trig function. So I want to do my Desmos, and I'm going to clear out whatever I had, and I'm going to hit my function key for Desmos, and I'm going to hit my inverse tangent, and I believe it's 6 over 15. Yep. So 6 and divided by 15, and then I'm going to use my arrow key to go over, and I'm going to hit enter. So it looks like it gives me 21.8 for that. 21.8. Okay, so that's my answer for what angle it is. So that's actually in degrees. So if I want, I could put the character degrees in there, but that would be hard for me to get that character. So I'm just going to write degrees. Now that we've had some practice, why don't we try to draw some things? I know you're very excited about drawing things, so I'm already up to 7 minutes. I already have pictures drawn. So Brian's kite, and let me just get over here to my page so I can read from it, and I'm going to do the full screen here. Okay, so Brian's kite here is flying in a field on the end of a 65 meters of string. So if this is Brian, right, and his kite is way up there, hard for me to do it from this side. So his kite is way up there. So where is the 65? The 65 is right here, because that's where the string is. Okay, so the 65 is right there, because that's where the string is. I'm not doing a good job with this. Here. Okay, so that's getting in the way of the light, but that's all right. It's a poet, and I didn't know it. All right, so what's the angle of elevation is 70. How high is the kite? So the kite, how high is it? So here would be how high it is. Yeah, here's his head, but this is how tall it is, how high it is above his head. So what trig function is that? Well, let's see. That's my opposite. Here's my hypotenuse, and here's my adjacent. So I have something on opposite and something on hypotenuse, so that's sine. So I want to do the sine of 70 degrees equals x over 65. This way. Okay, so the sine of 70, oh, that 70 looks really, really bad. Sine of 70 degrees equals x over 65. So all you would have to do is multiply the sine of 70 times 65, and that'll give you your answer. So when I take a look at number 2, it says from an airplane at an altitude of 1,200 feet. So 1,200 feet is how high up the plane is. So I'm going to put 1,200 right there. So the plane is 1,200 feet in the air. The angle of depression to the ground is 28. So 28 is actually here. If this pilot looks straight across, he wouldn't be able to see the building. He has to look down from his straight across vision. So that's the 28. So if 28's there, then 28 is also here. Okay, so I put a 28 there, and I'm just going to move that out just a little bit. Okay, so I'm going to put the 28 there, and it says, find the distance from the plane to the building. Well, wouldn't that be, here's the plane and here's the building, so it's right there. So it's the hypotenuse, right? So here's the opposite. Here's the hypotenuse. So again, it is going to be sine. So I am going to use sine for this as well. So I'm going to say the sine of 28 equals 1200 over x. Okay, but something you're going to have to realize with that is that you have to do the switcheroo, right, with that. Where sine of 28 is, you're going to have to put the x, and where the x is, you put the sine of 28. So you would write x equals 1200 divided by the sine of 28 to figure that one out. Looking at number 3, from a point on the ground, 12 feet from the base, so I can come up a little bit, you have a flagpole, right? The angle of elevation to the top of the pole is 53. So I'm going to put my 53 right here, 53 degrees for my angle of elevation, and that 3 doesn't look good. 53 degrees for my angle of elevation. There's a point 12 feet from the base of for the flagpole. So 12 feet from the base of the flagpole. Well, this is base. Base means along the bottom. So that's why I'm going to put my 12 there, because it's talking about the base of the flagpole. So I'm going to put my 12 right there. It wants to know how tall is the flagpole. So that's going to be my x right there. How tall is my flagpole? So here's my angle. I do my DTT with my squirt bottle, and I say, okay, so the height is the opposite. This 12 right here, it's not the hypotenuse, so the 12 is actually the adjacent. So that 12 is the adjacent. So what do I have with a trig function that's adjacent and opposite? Well, it's tan. So I'm going to say the tan of 53 degrees equals x over 12. Right, because it's opposite over adjacent. So to solve the tangent of 53 equals x over 12, you would need to multiply both sides by 12. Looking at the last problem, we have a man flies a kite and he lets out 100 feet of string. Okay, so here's our guy and here's our 100 because it's string, right? So he lets out 100 feet of string. The angle of elevation is 52. So I'm going to put a 52 here. So it's 52 degrees. That 0 looks weird on the page. So I have 52 degrees. It wants to know how far away is the man from the spot directly under the kite. So here's the spot directly under the kite. So blah, blah, blah. Oh, height. It wants two things. Wow, it wants a lot. It wants to know how high up off the ground it is, and it wants to know how far he is from that spot right above the kite. Okay, so it wants to know two things. So I could do two trig functions here. I could say, well, how high up is the kite are these two? So that would be opposite over hypotenuse for that, and that's adjacent. So why don't you fill that in for me for right now? Okay, so I have my opposite, I have my adjacent, and my hypotenuse. So to solve for x, what trig function uses opposite and hypotenuse? Well, that would be sine, right? So for x, I would say the sine of 52 degrees is equal to x over 100. That's how I would solve for x, right? And I would just multiply both sides by 100. How do I solve for y? Well, that's adjacent over hypotenuse, so that would be cosine. So I would say the cosine of 52 degrees equals y over 100, right? And then I would solve y, which is the distance between the man and the bottom or the ground where the kite comes in. I need to just stop talking, sorry. So that's how you would solve for x and y. If you have any more questions on that, please let me know. Already at 14 minutes, so I am going to stop. So please let me know if you have any other questions. I'm here for you, and the next time I do a video, it will be on the clinometers. Okay? Hope you guys are doing great.